Before getting into the programming portion of this is mostly going to be focused on the actual implementation in Java. I'm probably just going to completely remove what I wrote and redo it, make it a little bit cleaner, because as I was doing this problem for the first time, I was learning this concept of using Tarjan's algorithm. And I really highly recommend Tech Revision's YouTube channel. He has a really, really good explanation using a whiteboard of Tarjan's algorithm. It's actually really simple once you understand it, but at first it was a little bit confusing to me. And in general, I think I did like 98% of what was needed to get this problem right. But eventually I did have to look at the discuss section. And one thing that I did get wrong, and I only corrected it after looking, is for this, well, I'll get more into it, and when I get to it, I can mention it. But for now, I actually have a working solution. It works. I think it's a decent runtime. It's like, I think it's at least like 50% faster than most others, so it's all right. I mean, I usually try to be 20% or more just to be somewhat optimal. At least when I'm solving it. I'm actually using this Tarjan algorithm, so really it's less to do with me and more to do with just following the algorithm. Let's see. Come on, man. It's really putting it to work, man. Really putting it to work. Come on. Come on, baby. I believe in you, LeetCode. Come on. I pay you that premium price so you can have all that server space. I believe in you. Please submit. There we go. So 127 milliseconds, not too bad. Memory, not that bad either. So, a decent solution. This, what I'm about to do, has less to do with numbers and optimization and more to do with the solution and the problem itself. So let's just start this from the beginning. So basically, you're given a problem where you have to figure out where there is a critical connection in a network. A critical connection being that if you were to remove that one connection, that node or set of nodes could not be communicated with anymore. So for example, 1, 2, 0, 3, if I take the connection from 1 to 2 away, you could still get to 2 by going 1, 0, 2. If I take the connection from 2 to 0 away, you could still get to 0 by doing 1, 2, 0, 1, so you could do 2, 1, 0, or you could do, 0, 1, 2, and this is an undirected graph, so if 1 goes to 3 and 3 goes to 1. So basically the problem says there are n servers, numbered from 0 to n minus 1, connected by undirected server-to-server connections, forming a network where connections I is equal to A, comma B, representing a connection between servers A and B. Any server can reach any other server directly or indirectly through the network. A critical connection is a connection that, if removed, will make some server unavailable to reach some other server. Return all critical connections in the network in any order. So you basically want to look at the graph that's given, and from this graph basically say, of these connections, which one, if taken away, is critical. So for this given example, there's only one critical connection. So one thing that's a little bit odd about this problem, I'm going to sound like an idiot for saying this, but I'm used to on LeetCode, when you do the problem, they just give you the graph. So like initially I thought connections was going to be like a straight up, more than this. Basically, 0 goes to 1, goes to 2, and it basically is going to give you that, list of things you can go to, but it doesn't, so you actually need to create the graph. You need to create 0 goes to 1, then you need to create 0 goes to 2, etc., etc. So I'm going to create a method called create graph. I'm going to pass in the given connections, and I'm going to pass in the size n. Now this is a mistake I made. I don't know if this is a bit of ignorance. I still need to do a little bit of research on my own. But apparently, if I'm not mistaken, no, I take that back. Yeah, I do take that back. Never mind. The way I'm going to create this is I'm going to have the graph be a list, an array of lists. So let's do graph equals new list size n, and then now we will send the graph into connections, And then we'll make the create graph method public void create. Jesus, what am I having a stroke? Create grawug. Create graph. There we go. Public void create graph. And I'm just going to quickly create this method that is basically going to take in the connections that are given, as well as the list of graphs that we want to have. So we're going to have this be the parameter. And okay, I think I'm going to fast forward a little bit here. Alright, so I basically just created this create graph method. I decided to change the graph from an array of lists to an array of sets and just make it a hash set, just because I want to be lazy and just do graph from dot add to graph to dot add from. So it's basically going to be a list of sets, and the reason why I did a set is I don't know what the data looks like, and I don't know if there's ever going to be a case where I'm going to have duplicates. I don't know. I mean, eventually the idea is to visit nodes that haven't been visited, so it wouldn't be a big deal if there were dupes, but this might actually make the program a little bit more performant. Either way, figured why risk it? Just use a set. So we have the graph, and now the idea is that we're going to do a DFS search, and the idea is that we're going to be giving the current node, the parent node, which I'll make -1 because there's no parent to 0. Actually, we could do null and make it integers. No, I don't think it matters. If this was the case where this was a set of integers, then yeah, I would do that, but I don't think, I'm pretty sure this is just whole numbers, like positive integers, so I don't have to worry about that. So I'm going to give the parent, which is -1. I also want to give the graph itself. I also want to give it, should I give it or make it a class variable? I want to also give it a list of lists that will represent critical connections. Integer critical equals new linked list. So I want to give it a list of lists critical, and I also want to take into consideration, make a comment, we also want to take into consideration 1, nodes that have been visited already. We'll use, I guess, Boolean array. Visited. What else do we want to take into consideration? We want to take into consideration nodes low value. We'll use, we could use a hash map. Map or an array? Which one uses less memory? I guess we'll go with an array since we know the size. Or actually, yeah, we know the size. We'll use an array. We'll use low. Int low. We also want to take into consideration what do we also want to take into consideration? Probably an ID designation. We'll use an integer iter count. Let's do int count. And the last thing we want to take into consideration, this is one thing that I actually got wrong and it took me a while to realize, is at time of node exploration value of low, e.g. capture low value before recursion. Let's see, we'll use at, let's do int at time. So basically this last variable which I did forget about. Well, actually, I didn't really think about it, to be completely honest, and I made the mistake was originally I was using a hash map. Really, I could use an array for the low values, but what I was doing wrong was I kept comparing the low value at that point in time for the node. But really what you want to do is compare the... maybe this will make more sense as I go into it, but basically we want this array to capture the low value of the node at the beginning of the method before the recursive call, just so if it gets changed at any point, it persists. So I'm going to make these four things class variables. Private int count, make those zeros start off. Private int visited, or actually no, we want this to be boolean visited. Okay. Private, what else? Low, int low, private int at time. And then with the method itself, we'll define the class variables. Low is going to be a new integer of size n array. At time is going to be the same thing, size n, and then we also want visited to be equals new boolean of size n. And then that should be those three class variables that we need. I could have just passed this into the method, but to be completely honest, it's a little annoying passing that into the method. It's unnecessary. It's really up to you, whatever you want to do. So let's make the DFS method. I'll actually go through this and I'll talk while doing it. We'll make this void DFS. We're going to do int node, the current, I'll call it node, the current node. You know what? Let's just, as big as that word is, it's good. Current node, parent. What else? We need the graph, in which case is a set of, let's do that, set of that. And we also need the critical. And there we go, and there we go. So that is all we need for the method, and now let's write the actual method. Now, as soon as we get in the method, we're going to say that visited this current node true. What else? We also want to immediately take the at time value of this current node of whatever the low is, and in this case the low is going to be the low is going to be count. Should we iterate count at the beginning or at the end? Let's do count plus plus, and we're going to then do low current node is equal to count, so the first one will be equal to 0. What else? Or actually, just to keep this all in line with my own mental stability, I want it to be 0 for 0, etc., etc. Doesn't change anything, but you know, small things that make you feel good in life. So at time current node equals count. So we mark that this node has been visited. We're visiting it right now. We bump the count. We basically say that the low value for this node is whatever the count is. I don't know, as we recursively go through, count is going to go up. At time, we're basically saying that at this point in time, for current node, the value is whatever the count is at this point in time. And now we want to do a for loop, and in this for loop, we want to get the integers of graph current node. So pretty sure this works. Pretty sure set works the same way as list with the iterator if, hopefully. So let's see, int item graph current node. What we're going to do is, first of all, the reason why we're even including parent in the method is that we're saying if parent equals item Continue. We don't want to go backwards. The assumption is we're coming from the parent, so we don't want to go look at the parent. And then we're going to say that if visited does not, visited item does not equal true. So if we have not visited it, we're going to do a DFS. The DFS, the current node, is going to be changed to the item. Then we're going to make current node the parent. Then we're going to make graph is just the graph. Critical is just critical. Okay, and after this recursive call, we want to say that if at time current node is less than, if myself, the node myself, if I am less than one of my children after the recursive call, there's an issue, because my children should be either less than me or the same as me. So if I'm less than my child, low of item, there's an issue here, and that issue is that is a critical connection. So we're going to do list integer TMP equals new linked list. Okay, and what we're going to do, we're going to do tmp.add current node, tmp.add item, critical .add tmp, and by the bottom right here, what we're going to do is that as we explore new nodes and as we look at other nodes of our children, if our children is lower than us, then we take that value. So we're going to say that low current node is going to equal, you could do an if statement, or you could just do math.min current low current node or low item. So this is basically saying if current node is lower, go ahead and leave it as is. If low item is lower than low current node, then we're going to assign that low current node. This is why doing this messes up this. That's why we need the add time current node, just so we keep the same value, at least for the comparisons anyway. So we have visited, we have count, current, okay. If parent equals item, we're going to continue. If we did not visit this item, we will then do DFS with the item, and then the current node is a parent, passing in the graph, and the critical list. At time current node list and lower item, that's a problem. That is a critical. Go ahead and add that to the list. And I think that's enough for the solution. We're about to find out. Return critical. If I can spell right. Return critical. Run code. And there's an error. List cannot be converted to set integer. Where do we have that? Line 8. Line 8. Whoops. Whoopsie. Hash set. I think hash set is fine. We don't really need a linked hash set. Or actually, does it make a difference? I don't think it makes a difference. We'll see. What happened? Whoops. Again, whoopsie. Size. And whoops. Can I find symbol add time equals new and n? Whoops. Misspellings. Misspellings. Can I make a 19? Oh yeah, that's right. I made you Incompatible types. Integer cannot be converted to list. Connections graph. Whoopsie doopsie doo. Set. Can I find symbol below current node equals count? This is the magic of not having a compiler. Or I guess this is kind of a compiler. Okay, so it looks like I did it right. Looks like I did it right. Emphasis on the looks right part. Let's see, 6. Let's do another one where we have 3 goes to 4 and 5 goes to 4. Okay, let's see, this should work too. Okay. 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 So I believe I'm going to submit this, and hopefully I don't have any time issues, because I know in the past the way I was creating the graph was creating time issues, and the way I was doing the method in general was a little bit wrong. So yeah, let's see. Is this going to be a worse time? Is this going to get accepted? Is this going to be an okay submission? Is this going to be better, worse? Come on, leak code. Come on now. I believe in you. I really wish they would show you the test cases as it was running, because, like, I don't even know how many test cases there are, but geez Louise, is taking forever. Let's see. Now, I'm going to be honest, I don't know the difference between the runtime complexity of a set and a linked list. I am assuming the operations to be... What? Connection timed out. I'm assuming the operations to be similar in terms of, like, adding to a set. Matter of fact, I can Google it. What am I looking for? Time complexity of set add. Should be constant. Whoa. What? Oh, okay. Jesus, okay. Tree set is sorting. Okay, so yeah, it's constant. Alright, so the add is constant. I'm not removing anything, even though that's a constant too. Alright. Well, wow. It's worse with a set? So, I don't know what I did differently, really. I mean, for the most part, I did everything the same, but I guess that this solution using a set is worse than using a linked list. Go figure. Either way, it was accepted. I'll probably look and see if I made any, like, small mistakes in terms of if anything could have been faster. But that's the solution. I'll put this in a paste bin in the description just for, clarification purposes. Again, looking at this method doesn't look very hard. Looks really easy, actually, but me made big mistake early on where I was not using a visited array, because I figured, or actually I was using a visited array, but I was not using the at time current node index array, which basically blew up in my face, and it didn't work out the way I thought it would work out. There's a couple issues I had early on. I mean, I learned this for the first time. Very easy once you understand it, but definitely, anything with recursion, especially when it has something like this where this operation only really makes sense on a recursive callback, because it's only once you're exiting the explored node that you care to check that, hey, where I'm coming from, am I less than where I came from? Because if I'm going somewhere and I'm already lower than the person I'm going to, that's an issue. So that's basically a critical connection. But yeah, this is a pretty annoying problem. I really hope I don't see this problem on an interview, just because of the fact that just making the graph took me like 5 minutes. Not to do it, but just to figure out, like, oh, I actually need to make this graph, which is like killer in an interview. Anything that's ambiguous is like destructive to my productivity. But yeah, pretty straightforward. Again, I'll put it in the description. Hopefully this helped in terms of just explaining things a little bit more. Maybe don't use a hash set. I don't know. I don't know the time complexity of the hash set, although I don't see why that should be worse than what I was doing before. It was literally just a linked list. But either way, that is pretty much the straight and narrow of it. If you have any questions, I really would recommend that you check out the discuss section of this problem. Pretty decent examples that'll help you out. And again, that YouTube video that I mentioned earlier is actually really good, and he has some really good examples in terms of walking you through the whiteboard and just kind of giving you a general overview of Tarjan's algorithm.